world's a maze, a tangled thread. Servers spin inside your head, but a new dawn breaks a different way. WebAssembly's here to light the day. Spin it up, the future's bright. Microservices taking flight. Thorsten Hans, he'll show the key to build and run effortlessly. From hello world to APIs grand, AI's power at your command. JavaScript, TypeScript, take your stand. In Fermyon cloud across the land. Spin it up, the future's bright. Microservices taking flight. Thorsten Hans, he'll show the key to build and run effortlessly. Secure and fast through coding veins. Join the stream, don't be late. Unlock the future, innovate. Spin it up, the future's bright. Microservices taking flight. Thorsten Hans, he'll show the key to build and run effortlessly.
Hello and welcome back to the Rawkode Academy. This is Rawkode Live, the show where we take a look at cool open source projects in the cloud native space. Today we're going to take a look at Fermyon Spin, but through a slightly different lens, based on some of the announcements they made just last week at KubeCon. Guiding us today is Thorsten Hans. Welcome back. How are you?
Hi, David. Thanks again for having me, and hello everybody on the stream.
Yeah, always an absolute pleasure. For anyone who hasn't caught us, streaming together before, could you just tell people who you are and what you're up to?
Yeah, as David already mentioned, my name is Thorsten. I work as a senior cloud advocate with Fermyon, where I mainly, am on streams, write technical docs, blogs, or help developers taking our products and services and our open source projects to build software for the upcoming future, right? For the next decade, maybe. Yeah.
Awesome. Thank you. And you were at KubeCon last week on the Fermyon booth talking about all the wonderful things that the team have been up to. So I know there's a number of announcements. Do you want to give us the quick rundown of what Fermyon has been doing in the last couple of months?
Yeah, sure. So yeah, the both of us were in London for KubeCon EU, and yeah, as David mentioned, we had a booth there, and we introduced Fermyon Wasm Functions, which is basically a fully managed hosted service that we provide on top of Akamai's global connected network. So we took, like, over the last couple of months, we took the way how we run spin apps in a dense and available fashion and put that together with Akamai's globally distributed network and locations that they have around the globe to, basically provide a service where we as developers can just take our spin apps, deploy them there, and we don't have to care about nitty-gritty details like selecting a region, right? So apps are always available and requests are routed to the closest data center depending on from where the request is hitting the app, which is basically in a nutshell what Fermyon Wasm Functions is and what we were working on the last couple of months.
Yeah, I think that the understated thing about this, right, is like, anyone who has watched more than one video on this channel knows I love WebAssembly and building applications with this pattern. And I always talk about the performance characteristics of shipping WebAssembly, right? When we start a container, we're measuring it in hundreds of milliseconds, typically. However, when we're measuring WebAssembly, we're measuring in nanoseconds before that thing is actually returning some data back to the user. And, not the problem with Fermyon Cloud, I don't want to frame it in that way, but Fermyon Cloud, I believe, was like single region for the entirety of its kind of, cloud life, which means you have to fight the latency. If that user is in Australia, if they're in Asia, if they're in Europe, you don't really know where that server is, and we could be measuring it in 50 milliseconds, or we could be measuring it in 300 milliseconds, which is not the end of the world, especially when WebAssembly is fast. However, when you partner with Akamai, who probably have one of the biggest networks in the world, we're now getting this double whammy of, well, we're going to get that first byte, or that we're going to get that latency down to an absolute minimum, and then the runtime and the execution of that WebAssembly binary is then equally fast. And then it's like, who doesn't want that? Like, that is just the absolute ideal scenario for anyone that wants to ship and have their users be happy on a performance level, at least. You still got to write good code, right? We can't teach people everything, but when you remove that infrastructure component and that networking component, I mean, that's a win. I mean, hands down, that is an absolute win. I was so thrilled to see this announcement. So,
yeah. So basically, how we phrased it, we we married the fastest serverless compute with the fastest network available to provide like lowest latency for execution, right? Of serverless workloads. Yeah, and the cool thing is, for us as developers, nothing changes, right? We can still use Spin for creating WebAssembly workloads, or you can create them using different tool chains as long as they align with WASI incoming HTTP handler, for example, right? To build apps and deploy them there. However, as always, we are super keen to deliver a great developer experience and extended the Spin CLI to make it aware of that new Fermyon Wasm Functions service, where you can deploy your apps, you can, inspect all the apps running on your account, and, different like inner loop concerns are obviously addressed by default. Yeah.
awesome. So, do you want to give us a bit of a rundown on what it is you're going to be walking us through today? I mean, I think we've all got a pretty good idea based on what we're talking about, but yeah, what are you going to be showing us how to achieve today?
Sure. So
You want me to jump over to the screen share?
yeah, that would be great.
All right. You are now live. Take it away, Thorsten.
Okay, cool. Thank you. So what we're looking at right now is basically the announcement post. I think we can put that link in the show notes later on, which is giving you an overview of what Fermyon Wasm Function is, what it offers in more detail. Obviously, as always, we try to provide best-in-class documentation. And if you're familiar with what we do, right, with Spin and SpinKube, or the CNCF projects we contributed, we have obviously reworked our website to make it a little bit like clearer where to start, right? So as a developer, you obviously start with building apps, but at some point in time, you want to deploy and run them. And there is right now a new section over here, Fermyon Wasm Functions, which, gives you all like details about how to do X, Y, and Z within Fermyon Wasm Functions. But also there is the request access button, because right now it's in preview and we have to, or we let people in once you request access to the service. So that's a great resource where you can find samples, tutorials, guiding you as a developer through the process of building your apps and getting them deployed to Fermyon Wasm Functions, and also some let's say, more details about how this works. And I think that's a good starting point to become a little bit more technical, right? So our service comes with its own registry, right? So as for like more than a year, yes, I think we stick to OCI artifacts as distributable units for spin apps. So if you build a spin app and you want to distribute that, you always end up with an OCI artifact that is pushed to some sort of OCI registry. So basically a registry that implements the Docker registry 2.0 standard. And yeah, we provide one as part of Fermyon Wasm Functions, which basically receives your workload and ensures that it is deployed across the globe. And as soon as all the regions report back that the app is up and running, we register a subdomain name for you with an HTTPS certificate so that you can immediately invoke or send requests to your workload. Or you can, if you if you are already using Akamai products, you can integrate them with existing Akamai products, right? That's possible. So to route through a property, how it is called in Akamai, to your Fermyon Wasm Functions. On the backend side, nothing changed, right? So you can still interact with databases, with key value stores. And again, we provide as part of our service offering a globally distributed key value store that you can just use as you're used to use it with Fermyon Cloud, for example, right? So it's really like an incarnation at the next evolution step on how to run spin apps on a fully managed platform. All right, so what do you need to get started? I think that's always the most important information for us as developers. So I have installed Spin on my Spin -- version on my machine in the latest stable release. That's version 3.2.0. And I have also installed a new plugin that's called Akka. That's basically the plugin, for interacting with Fermyon Wasm Functions. You see already like familiar subcommands like apps, manage applications, or to deploy an app, to log in, and so on and so forth. So we will go through that entire workflow once we have implemented an app that we can deploy to the service. The most important question at this point might be, how can I get that Akka plugin? And again, the documentation provides a quick start where you can, find information on how to install Spin and how to install the plugin, the Akka plugin that I have already installed on my machine. This is especially handy if you have already Spin installed on your machine, or if you installed it before we released that plugin, right? As always, language-specific tooling is required. So if you want to write your apps in JavaScript, TypeScript, you need Node installed on your machine. If you want to write your apps in Rust, you need Rust installed with the WASM32 WASIP1 target. And if you want to write your apps in Go, then you need TinyGo installed in a recent version. I think I've installed, let me check, TinyGo version 36. I think 37 is already out. So that will also work, but keep in mind to also upgrade your templates, because there was a rename of the entire WASM 32 WASI platforms at the beginning of the year. So for Rust, for example, it's now called WASI 32 WASI P1, and for TinyGo there was a change as well, right? So if you encounter some errors following the guide, building the app, chances are pretty high that you hit exactly that, change from the underlying platform name. But that's all we need, right? We need the Spin installed on the machine. We need language-specific tooling and that Akamai or the Akka plugin. So the service is a multi-tenant service, which means we have to authenticate in some way, right? And we use and love GitHub, so we use GitHub as an authentication provider. So once you have requested access, and the onboarding is completed, you can do a Spin Akka login over here. And that is a regular device code flow over here, where I can say I want to authenticate with my individual GitHub account, and then I have to grant the CLI the permissions to interact with Fermyon Wasm Functions on my behalf, right? So I can close that tab right now, and as you can already see, it welcomes me, and now I have access to my account, where I can do things like obviously deploy apps, or I can simply say apps list to explore what's already there. And as you can see, I played around a bit with Fermyon Wasm
You've just got a
Functions.
couple.
Yeah, and I cleaned up a couple of them already before the stream. So yeah, you get the list of the apps deployed to your account, and as you mentioned, David, the both of us were at KubeCon. So let's take this one for example. You can do a Spin Akka apps info. Oh, I think it was without a dash. Yeah, it was without a dash. And you can see that I deployed, however, never invoked the app. No, I did not invoke it in the last 7 days. So I deployed an app there that is available at this URL, and it basically prints hello world, a quick build verification demo. So I think the key point is it's a super intuitive sub-command to the Spin CLI, addressing day-to-day concerns. And we will obviously right now start building something. And for those of you who were on or joined the last stream, where I ran into some issues with the IT router in TypeScript, there are also great news in regards to the HTTP, TypeScript, and JavaScript templates. Let's say hello Fermyon Wasm Functions, and let's add a 2 to be safe. I think I have one already. So we updated JavaScript and TypeScript templates since David and I were on stream last time. And the new templates allow you to choose from different routers, because I think I like Hono pretty or a lot, and I think its API is super memorable, at least to me. And but maybe you want to roll without an HTTP router, right? That's now also possible. So let's.
I like Hono as well. It's a great little mini framework. And you're right, the developer experience, the API surface of it is slick. So.
Yeah, it is super great, especially like its middleware APIs. I like them a lot, and stumbled upon it a while ago, and so we updated our templates, so that's also new. So let's jump right into hello Fermyon Wasm Functions 2. Let's open up code, and let's increase the font size a bit. Again, nothing new over here, right? We have package JSON, like an idiomatic JavaScript or TypeScript in that case project. However, right now the dependency added to the project is Hono instead of iti, but you can choose whatever, you know, which router you want. So before diving into code, let me do one thing. Let's do a quick spin build, because spin build also runs an npm install if that hasn't been executed in that project, to pull down the dependencies, and which, you know, is basically turning on the lights to get IntelliSense and auto completion and stuff like that in VS Code. All right. So the skeleton that we create when using Hono is giving, like, you know, some simple guidelines on how you can use capabilities provided by Hono, such as the built-in logger, like a middleware that adds a response header, and 2 get routes, right? So pretty default hello world experience. Let's save that as it is, and we will, you know, change that and enhance that during the stream. But let's give it a try, right? Let's say spin build. So we updated a couple of I removed a couple of comments. So let's build that again. And now that is built, I can do the usual spin up to test it on my local machine. I can curl localhost 3000. I get back hello spin, and I think if I say hello, no, not greeting me, let's greet David. There you go, you get hello David. This time that is, if we look at the headers, we get JSON back. In contrast, the root route was a plain text response. Okay, so it works on my machine. That's great. We see that we get logs provided by the Hono logger middleware. Let's take that app and let's deploy it to Fermyon Wasm Functions, which is as easy as doing a spin aka deploy. And right now it's taking, you know, the Wasm file, the spin manifest, creates an OCI artifact, push that to the Fermyon Wasm Functions registry, and now it's deploying the application across the globe into all the regions that are part of the service.
So we had a question in the chat about that,
Sure.
actually. So I'm going to bring it in now, but Paul is asking, how many POPs are there on this network? How many regions are we deploying to?
So there's a difference between points of presence, POPs, and regions. I'm not 100% confident how many regions. Let me quickly look up. So list of countries is pretty damn long. I try to come up with, we have over 4,200 edge points of presence on the Akamai connected network. And the service is right now, we operate it not in all regions provided by Akamai. So if I remember correctly, we're currently running in 6 regions as part of the preview. However, we are super happy to stamp out new regions and, you know, grow during the preview period as well. So I think yesterday and the day before we extended we added 2 more regions. Before that we were running on 4 regions. So that's growing, but obviously once we move out or graduate out of the current preview phase, we will distribute it across all the regions that we could deploy to.
Awesome, thank you.
Yeah, great question, Paul. Sorry for not remembering the number from top of my head, but yeah, it's more than 4,200 POPs. Okay, so in the meantime, deployment, it roughly takes a minute or so to deploy or to ensure that the app is deployed across all the regions. It happens in parallel, so we expect like the same, time frame, no matter how many regions participate or are part of the service offering. And we end up with a generated subdomain under aka.fermyon.tech, which you can obviously, put behind your first line of defense or your DNS configuration, right, to expose it under your domain name. So let's curl it, and we get a hello spin, and I think it was hello raw code. Let's do that. There we go, and we get back the expected result. If we take a look at the headers right now, -I, we can see that the closest one for me is the European Central region in the Akamai cloud. This is due to the fact that I'm based close, like 150 kilometers away from Frankfurt. Yeah, if I would live like a couple of kilometers further south, chances would be better to end up in a France region because I'm so close to the France border. But that's like an indicator that you can see, hey, which region handled that particular request.
Can you drop that URL in the chat for me? I'm just
Sure.
curious. I want to see if I'm going to get EU Central or something else.
Sure. Let me copy that, and there we go.
Thank you very much.
Did you get it?
I got it. Yeah.
Okay, cool.
Doo-doo-doo. I got Paris. There you go.
Paris. Interesting.
Well, yeah, I guess that's. I'm in Scotland, so
Okay.
that's pretty good. Yeah, I'll take that.
There's another interesting header added over here. We have that X envoy upstream service time, which is basically telling you after entering the network, the Akamai network, how long in milliseconds did it take to process that entire request. And we see 4, which is I executed the request a couple of times. It's higher as I expected it, and that's due to the fact that the app writes to standard out, right, which is always an expensive action, right? So if you strive for best perf, obviously Rust is faster, or Rust code compiled to WebAssembly. That's the original, the correct explanation, is faster than taking JavaScript or TypeScript and compile it down to WebAssembly, because the binary does not have to, contain a runtime like a JavaScript runtime. So there are ways to get even lower, like to 1 millisecond or less. Okay, now we have that hello world deployed, and we can do spin aka logs over here to get like the logs that this particular app produces. And the plugin is smart enough to recognize, hey, you're still in that folder where you created that application. So it can determine the actual name of the application by investigating the current folder, right? So if I step out of this folder, and if I do a spin aka logs, it says, hey, there is no spin toml, right? I don't know which logs I should present. So I can say, oh, there's hello KubeCon. Okay, I don't know if that one created logs. Fermyon Wasm Functions 2, then I provide the name of the app, right? And I can, obviously also inspect how an app behaves at runtime. If I don't have access to the source code, or if I am in a different corner on my hard disk. Cool. So this is super simple hello world. But what are typical use cases, right? So we thought about besides, let's call it line of business applications. So I don't know, CRUD over a database, or you know, interacting with the key value or loading data from a key value store. What are typical use cases? And what we created, this is a public repository, and again, I will post the link to, or will send the link to you, David. This one, where everyone could explore a couple of samples that we created as part of tutorials, or just that we think are super valuable for, you know, doing computation close to the user, instead of, you know, routing the request around the globe to a data center that has been selected. So there are a couple of A/B testing scenarios, traffic filtering, blocking requests based on user's country, and stuff like that, right? Response header modification, gated access, so a limit access. That's also pretty interesting. So imagine you have like you have an embargo, right? And you want to do a hard launch at a particular time. Then you can easily, because the execution is so fast, right? You can just say, hey, up until 11:59 a.m. return a 404, and starting at noon, just open the gate and let people in, right? So there are interesting scenarios that you could achieve with running closer to user, when you could place computation, with low latency instead of the regular way to the data center. And I thought it would be great to take one of the examples and implement it from scratch. I would say like a simple A/B testing scenario to return different content based on a key value store. So obviously, and I think this is super important for like enterprise scenarios, or like, you know, extending existing software products, you can provide your own key value store, right? That could be in your cloud of choice. That could be, I don't know, a hosted one that you expose through your private network, whatever, right? You can provide your own, but we also provide a globally distributed key value store as part of the service offering. And that's what I will use for demonstration purposes right now. Okay, we start again with, let's check what we have over here. Good. So let's do a spin a new HTTP TS again. And I think after that one, we will do a simple Rust to illustrate that, hey, every language works. But let's say this is the AB key value, AB testing sample. Let's call it that way. Okay, we want to respond to everything, and I like Hono, so let's stick with Hono. And let's do a spin build again to ensure all the dependencies are installed.
Can I ask some questions just about
Sure.
the setup right now? So, you know, this is the second time we've spun up a TypeScript thing, and I think, you know, anyone following along at home that wants to do this too, what they're going to see is, one, NPM is used and Node are used by default, and Webpack is used as a bundler. So, as someone who writes a lot of TypeScript myself, there's obviously a lot of momentum now to alternative runtimes. I'm talking about Dino and Bun, as well as almost mass migration away from Webpack to things like ESBuild. So my curiosity is like, okay, do I have the options to use Bun or Dino instead? Can I replace Webpack? And if I can, is this as simple as me creating a new template and submitting a PR? Like, how does this all work under the hood?
That's a pretty good question. So let's take that question and go to the Spin.js SDK. So obviously the JS SDK, as all the Spin repositories, has been moved from the Fermyon organization to the Spin framework organization on GitHub as part of Spin being accepted as a CNCF sandbox project. So that's why there is a different URL. And there is the Spin JS SDK. So there are templates that, are provided that you can install on your machine. Obviously, you can roll your own templates. So if we sneak into pull requests, there is add support for Yarn, which we postponed a bit because we brought in Hono and we did some major refactorings about modularization that I will explain in a second. But in regards to the build tool chain and package managers, there is obviously a way to, customize what happens. A Spin template, let me zoom in a bit, always consists of two things. You have that metadata file that describes what this template is all about. That could have like parameters, right? So HTTP router being the new one over here. And there are two ways how you can create a new component in Spin. One is that Spin new that I did like 2 times right now. I choose a template, and then basically everything from the content folder over here will be dumped to your desired folder, right? With some, replacement happening in template files and so on and so forth. Yeah. However, there's a second way. You can always add an additional component to an existing Spin app. And that's, I think it's valuable to understand that that's why there is a dedicated component txt over here that will be merged into your existing spin.toml. And if we look into the package JSON, you can see there's right now npx webpack being executed before J2 Wasm is basically responsible for taking the JavaScript source code that Webpack created with our templates and, turning that into WebAssembly. So obviously you could submit a PR, replace Webpack with ES build. Definitely possible, right? Regarding the runtime, so the JavaScript SDK for Spin and the underlying tools, the build tools, so Spin framework build tools, they're responsible for turning your JavaScript source code into WebAssembly. And as part of that, a runtime must be shipped or must be compiled to WebAssembly as well. And we are currently using Starling Monkey, which is a bytecode alliance project that is, the runtime. I think it roots from SpiderMonkey, the runtime, from Firefox, right? It, in addition to other runtimes, it implements all the service worker specs and so on and so forth, so that regular fetch APIs work as you would expect them to work. Swapping out that one is also possible, right? As long as the desired runtime could be turned into a WASI or WASM WASI P2 compliant component or in a WebAssembly component. So I don't know if Dino or Bun could be turned. I haven't looked into that, to be honest.
Dino can certainly run WASM and import WASM. But I don't think moving away from Starling Monkey is a good idea. I think that is the right move. I think looking now that I understand how this is built under the hood, if you go back to your template one, right?
Yeah.
Really, I just need to update the build steps in my package JSON. Webpack, right. I'm pretty sure I can remove. Even Dino has a bundle command, which will give me a bundle.js. So then I could just run the J to WASM and hopefully it would work. What is the responsibility then? Sorry, I know we're getting into the weeds of it now. What is the responsibility of the build tools package? What is that doing?
So that's a good question. Top of my head, we have to look into that. Let
Yeah,
me
go take a look.
spin framework. Come on. So the build tools, I expect them to be good. No, maybe
Maybe it's in the JS SDK.
yeah, maybe it's
No?
maybe it's a yeah, that was the wrong one. Maybe it's a package being packages. So yeah, there it is. Oh yeah, it's basically wrapping componentized JS, and yeah.
Oh, it's a web
Okay.
plugin.
Yeah,
Okay.
it was basically me catching up with like recent modifications right now, a talk. So over the past couple of months, there were a lot of improvements to the JavaScript SDK and the JavaScript templates that happened, right? So our intention was to make Spin projects with TypeScript and JavaScript more and more idiomatic, right? A couple of weeks ago, you ended up with a folder, a nitwit configuration file that defines which as WebAssembly interface types words must be imported by your component and what's exported, right? And although that is super useful to some degree, if you want to, become or implement more advanced capabilities or to compose complex systems from multiple components, things like that become super important, and you want to tailor that maybe at some point. But for the majority of workloads where you want to, create an API or interact with, as we are going to do with key value store, we wanted to have the project as clean and simple as possible. So we try to, pack more and more into like dependencies that we add to the project, instead of having you to maintain or to track that in your source control. Yeah.
All right.
So once we are here, we also started modularizing the Spin SDK for JavaScript, so that you can now precisely pick and choose different capabilities when building Spin apps. And which is basically what we will do in a second. So we created an app right over here, the A/B testing sample app. We built it, so we downloaded and dependencies, and we turned it into a WebAssembly module. That was just me to ensure my VS Code is happy and I get, IntelliSense and stuff like that. So the idea is to implement an A/B testing and based on key value store. So what I have to do right now is I do an npm install at spin framework /spin-kv, which adds that as a dependency to my application. And from now on, I can use the Spin APIs as I'm used to use them. So I can say over here, import star as kv from at spin framework. There we go. And now I could start using them. So we'll do that in a second. But first, let me do some housekeeping over here. All right. So we still have the logger. Yeah, let's have the logger. Let's stick with them. And we want to basically expose a get endpoint at root route, which gets the context from Hono. And over here, we will do the following. So let's say every even request should return something different from every odd request. That's the overall idea of that sample, right? And to do that, we track like every invocation of that application. So we can use Hono middleware for that. So that's async, and again we get the context, and we get next. All right. So this is basically allows us to run code before the actual handler, and then we say await next, and then we can run code after the actual handler. And that's what I meant at the beginning of the stream with. I really like their middleware syntax and the way of how to structure your app. It reminds me a little bit to, like aspect-oriented programming, where you can take an existing application and enhance your handlers, or enhance your app before the actual handler, or before the handlers and after the handlers. I like that approach really much.
Yeah, I mean, a great use case here is like making sure you respond to your users or customers as quickly as possible, and then anything that can happen after the fact. I'm thinking analytics or event processing and stuff. You just do that after, and then it doesn't affect that response latency.
Right. So there are numerous use cases where this is super handy, right? Where you can send a response and keep on computing to finalize, or to, whatever, take your bucket of data that you collected throughout the request, but then push it to whatever backend you have to push it to, but already present the answer to the user. And we'll do slightly something similar to that, right? So the idea is to have a counter, right? So let's say interface counter, which has a count. That's obviously a number. And we want to store and retrieve that from the key. So I like to get rid of magic strings. So let's say hits is a constant. That's our key that we will use. And let me push the code a little bit to the upper. And so key value, as always in Spin, we have the concept of a store. So KV, you can see you can open a named store, or you can open the default store, which is the store with the name default. So let's open the default store over here, and let's initialize the counter for now. Counter equals count is 0 as counter. As soon as the microphone is above my keyboard, it feels wrong, right?
Yeah, every time there's a camera in my face, my typing goes to absolute crap. It's a rule, right? That's it. That's how it works.
That is how it is. That's true. Okay, so we initialized that counter with 0 because it could be the case that my app has never been invoked, right? And I want to use that value from at that point. So let's say store if a value at key exists, then we obviously want to take that value instead. So we can say get JSON over here at position key and cast that into a counter again. So this is basically if no one execute or send a request to our app, we start with a count of 0. Otherwise, we just take it from the key value store and use whatever is stored in key value store. And now we can easily pass that count to the handler before invoking it by saying, hey, context, please set a value called count to counter.count. Okay, then we invoke our handler. So let's implement that, and that's pretty straightforward, right? We again have to load the count, so we can say count equals number. So we parse whatever we get to a number, because this API returns an any at position count. Okay, let's get rid of that one as well. Context. Oh, that's Rust. Context key equals, and let's say count. And let's use single quotes over there as well. So let's use that as the value, and then we can grab that from here and get rid of the magic string. Okay, so we have the count right now as a number, and then we can easily say, let's roll with if count modulo 2 equals null, then we want to return, let's say return c.html h1, let's say even, and otherwise let's return over here, right? Just a simple example. So we have successfully read the value from key value store. We have implemented like the A/B testing algorithm, super fancy right now. So what's missing? Obviously, we somehow have to store the value. And this is what we want to do after the invocation. But we can't simply, set it as it is. We have to increment it. So we say counter.count plus equals counter.count plus 1. Obviously, we can also use the shortcut there. But ultimately, we call store set JSON, and we set at position key, we set counter. Okay, so that's basically the implementation of our app that we now want to deploy to Fermyon Wasm Functions. However, there's one important thing missing. As always, WebAssembly has that deny by default security mechanism, so we can't make use of external resources without specifying that, and a key value store is no exception here. So that happens in the Spin manifest, where I can say, hey, my A/B testing sample component should or requires a key value store. So you could request multiple. And as I use that open default method, right, that's just syntactic sugar that executes open default, right? So that's why I have to explicitly provide or ask to make use of a key value store called default. Okay, I think that's ready for testing, or compiling first and then testing, right? So Spin build, it recognized, okay, there was some code change. So there we go. App built successfully, and spin up again. Now I can see, okay, you requested the default key value store. In the case of doing a simple spin up, Spin will take care of creating a SQLite database for you that acts as a key value store on your local machine. So let's do curl localhost 3000. And we get even, and we get odd, and we get even, and we get odd, and we get even, and we get odd, and so on and so forth, right? So simple key value based A/B testing. So now let's take this one and throw it over the wall to Fermyon Wasm Functions. And that's again as easy as doing a spin aka deploy. And the same thing we saw earlier, right? Packaging the app, distributing it, and making it available across the globe. Are there questions that we can take in those 60 seconds?
I mean, I have one.
Sure, go ahead.
So now that we've got these WebAssembly functions on the Akamai network, right? We've already discussed the merits of that and the fact that it is one of the biggest networks in the world and you're adding new regions, right? So is the Akamai CDN in front of this? And I'm asking that because I'm curious. If I return a cache control header on some of these functions, will the CDN cache that for subsequent requests?
That's a pretty good question, and I think we were already at this one, right? I brought that, right? It's not there, right? Yeah, there we go, right? So we can obviously integrate with the CDN which sits in front.
All right, so can we add a cache control header to the endpoint then?
Sure, let's try.
I know it's going to then add another 60 seconds and I'll have to think of another question.
Okay, but let's try it. Oops, even. Yep. Odd, even, odd, even, odd, even, odd.
All right, so let's break that then with cache control.
Let's break it by adding a cache control header. Okay, let me do one thing. Let me quickly curl. Oh, no, not curling that one. Let me curl this one with -i. So these are the default headers. Okay, obviously we have more latency because we right now talk to that to that key value store, right? But yeah, let's go to this one, and let's easily add. We can do that over here. C.header. Is that a property? Okay, so we can, no, I think we can simply set that. Yep. And what do you want? You want?
So it needs to be cache dash control.
Cache control,
And
okay.
then you'd have to set max dash age equals 10 for 10 seconds.
10.
Equals.
Okay, yeah, sorry. Sure, yeah, makes sense.
Yeah, so that should set, remember this response for 20 seconds.
Okay, so let's do that. Oops, like this. Okay, cool. So let's do spin aka.
Do you have to build it first?
Spin build. Yeah. Good catch. But I think you can easily also use the dash build, the same experience as you have with spin up or spin deploy, right? So,
Right.
okay.
So while that deploys, I've got more questions for you.
Sure.
So these examples are great, right? They're really revealing how the Akamai integration works and the cool things that we can do, and the Hono stuff. The Hono stuff is great. Like that is now my default for all TypeScript spin things. I was never a big fan of it. I like Hono. Now, what if I need some credentials and configuration passed into my application? What if I want an endpoint for like an S3 bucket, and I also want to pass in the access and secret key as secrets? What is the flow to do that?
Good question. Good question. So, as obviously there are sensitive and non-sensitive configuration data that you want to use within your application, and you can specify them as part of executing spin-aka deploy. So there are flags where you can specify your configuration values, and the important thing is the value or the configuration values are tied to that particular deployment, right? Because right now I'm issuing the second deployment of that app, right? And it could be the case that I introduced variables with that update right now that haven't been there before. So I think that's something you have to, if you start adding variables to your spin app and you want to do spin aka deploy variable, you see there are some I hope not that sensitive, no, not non-sensitive variables that I specified over here. On the service level, obviously everything is encrypted. All the variables are encrypted and only exposed to that particular deployment or version of your app on your account. So
Does that mean every
definitely-
version or every deploy gets its own unique URL?
No, it does not. We are currently operating in latest is available at. It's always, this one is
Okay.
always pointing to the latest version.
Okay, gotcha.
Okay, so let's try if we broke our A/B testing on purpose. So we get even. We get even. We get even. We get even.
Can you add a -I to that? We should be able to see the cache
Sure.
stuff as well, right? Yeah, there we go.
9. And the funny thing is, that I bet the first request after cache expiration will also be even because the value is now even in key value store.
Well, I don't think the value should
Oh,
be
it's
changing.
on.
Yeah, there we go. Yeah.
There we
That's
go.
awesome.
Yeah.
I didn't know if that was going to work, but having the Akamai CDN sit in front of all of it, that's super cool. I love that.
Yeah. Yeah. Okay, so we have that. We already explored logs, right? So that was a spin aka logs, right? Sure, that should work. If the app write logs, and some logs.
Yeah,
are
only
there.
2 requests, which is exactly what I would expect with the cache control. So yeah, lovely.
Yeah. Okay. On top of that, we are obviously, adding more and more capabilities to the Spin Akka or to Fermyon Wasm Functions and to the Akka plugin that we provide. You can generate tokens, to do CI, CD workflows where you deploy straight from GitHub Actions to your account on Fermyon Wasm Functions. I think that's so. Let me quickly give folks an overview of what you can expect there, right? You can create, delete list, and regenerate personal access tokens. What you expect from, to basically do continuous deployment.
Can I ask another question? Is that okay?
Sure.
Sorry, I don't mean to cut you off. All this stuff is what I would expect to work with the Spin Cloud plugin, right? Like there's a lot of overlap here between the Akka and the cloud. So my curiosity is, one, if you log in to Fermyon Cloud, will you see your Akka functions next to your normal functions? And secondly, do we get all the same features we had with Fermyon Cloud? Can I do a custom domain on a Akamai deployment?
So both are great questions. So to answer the first one, if you log into cloud.fermyon.com, you won't see your workloads deployed to Fermyon Wasm Functions. Yeah, we're still in preview. Maybe there will be a new UI. I don't know. I don't know yet. To be honest, I don't know yet. So no, you can't explore like the Fermyon Wasm Functions from within Fermyon Cloud because those are two separate like platforms. The way how the entire building blocks of that servers are different as they are on Fermyon Cloud. And the other question was if what's the feature comparison or comparity to Fermyon Cloud, especially regarding custom domains. For example, our intention is as we run on top of Akamai to integrate with Akamai's services, and in Akamai there's a service called Properties, which basically allows you to bring your own domain, maybe use Acme or Let's Encrypt to acquire an SSL certificate, bring your own SSL certificate, configure your either simple or really sophisticated routing rules, and then route to the Fermyon Wasm Functions. So that's how it is today. That's how we designed that service to integrate seamlessly with what's in front of our service in Akamai. And so slightly different, as you may already know from, or as the experience is with Fermyon Cloud.
But as you said, this is in preview. There's still a lot of things to come down the road. So yeah, it's very exciting to see where we are at the moment.
Yeah. And one part of that preview is we have unstable cron jobs. So this is under active development, right? Because, I mean, building real-world application, HTTP could be like a great entry point to trigger a function, but also, I mean, maybe you want to run something on a schedule, right? So
Yeah, build my own status page, my own health checks.
for example, yes. So we try to, always iterate super fast and, keep it simple, yet maintain like the DX that we know. So creating a cron job is as easy as saying cron. Oh, there was one. Create, and let's say root route cron. Let's give it a name. Root. So every second minute, send a request to the root route at / and cron-root is just a name for my cron job, so that I can inspect or I can see it when I do a cron list. And right now the service will simply invoke that route every second minute. Right, so that's how it is today. We are obviously iterating over that and adding more and more capabilities to features like, for example, cron, to make it like full-fledged and bring more and more capabilities there.
Awesome.
Okay, so this is cron. We have deployed. Oh, we can do a spin Acker apps info. Let's do that. So we saw, fundamental metrics again. This is part of now trying to give the developers some insights about how the app behaves at runtime. That could be logs, that could be metrics, right? So basically laying the foundation. Cool. There's one more thing. The nice part, one of the nice parts of WebAssembly is its portability, right? So although we extended Spin CLI by adding that Acker plugin and creating the service, so the cloud side of things, we did not change anything to the spin apps. So spin apps remain like a WebAssembly component that exports a given capability, that imports given capabilities from the underlying runtime, which means we still can do things like taking the same spin app and say spin registry push and call that A/B testing for 1 hour. So TTLSH is like ephemeral, or we can browse the website in the meantime while it's pushing. TTLSH is an anonymous and ephemeral Docker image registry where you can store your OCI artifacts. And basically the TTL is defined by the tag that you provide when pushing your artifact. So everyone could right now, take the A/B testing app in the next 59 minutes and a couple of seconds and run that on maybe its own machine using the -- from A/B testing 1H. Oh, I think no, it's not from. It's spin up -- from. There we go. Right, so that pulls the OCI artifact, and you can do that on your machine right now, and you will end up with the same app running on your machine. So we have the app running on Fermyon Wasm Functions. We can run it locally using SpinUp, but we can also go ahead and simply deploy it to Kubernetes. So I have a Kubernetes cluster over here. Let's say kget ns, for example. That's 35 days old. Which one is it? Yeah, it's an AKS cluster with SpinKube running on top of it. So that is spinkube.dev, right? That's a sub-project of Spin, which means this is also CNCF, also a part of the CNCF sandbox project, which allows you to run your serverless workloads on your Kubernetes cluster right besides your containerized workloads. So you can right now simply do a SpinKube scaffold from point to the, however I called it, A/B testing for 1 hour, point to the OCI artifact, right? And without further ado, it's just printing it to standard out. So we can tailor this. We can, for example, say replicas. I want to start with 10 replicas. I want to integrate HPA. I want to integrate KEDA. If you have KEDA deployed to your cluster to scale horizontally based on how I call it contextual load, right? But we could simply say, hey, deploy this using kubectl apply and take std in. So we pipe the manifest to standard in of the following command, which is kubectl apply. And basically in our Kubernetes cluster, we now get a spin app, A/B testing. Let's do O wide. Yeah, this is the new one, which is pulling the image. So let's kill the old one. K delete spin app A/B spin. So let's K get spin app. So there's an executor, there's an operator deployed to the Kubernetes cluster that watches exactly that CRD. I deployed one, and then the operator moves on and creates a deployment for you, right? I specified replica, or I removed the replica. No, I specified replica as 1, right? That's why we see desired 1, ready 1 right now. So we see also a pod. However, the pod does not consist of containers. Instead, that's just a sub-process or a process on the underlying node, right? So there's no container involved here. And also the operator creates a service for you, allowing you to route requests to your spin apps. And if you scale out, you know, the Kubernetes service does its thing to route a request to one of the replicas. So we can do kubectl, or no, let's say K port forward to the service, or we could immediately directly point to pod as well. So A/B testing, let's say localhost 8080 to port 80 of that pod. And now we can curl 8080. And we have the same app without recompilation, without anything, running on an AKS cluster right now. And to be honest, I can't remember which architecture it was using. So let's check. I don't know if you see the architecture there. No, let's do a k-describe node. And I guess we can see AMD 64 is it for here. However, it doesn't matter. It could be an ARM 64, right? If you want to lower your cloud spendings, maybe it's smarter to roll with an ARM 64 instead of AMD 64. And the fact that we use WebAssembly means we don't have to do multi-arc builds. We don't have to cross-compile things. We can just take the same workload and run it on different operating systems, on different architectures.
All right, one more question for you then.
Sure.
That OCI artifact that you have pushed to a registry, if I have configuration which may be sensitive, is it inside of that OCI artifact? Is that something people should be aware of, not to push to public registries if there are sensitive information?
That's a good question. So if we go into the source code of our app, how do you provide configuration data? It does not matter sensitive or not. In the first place, to your spin app is you specify a variables block over here. We can say, for example, log level default equals debug, something like that, right? then so once you have defined a variable, that allows the runtime to pick up, for example, an environment variable to read that value. However, you have to explicitly give your component access to that variable. Testing sample dot variables, right? And then you can say, hey, take this from the application variables, right? So simple interpolation syntax over here. So now let's say you want to have connection string over there. Obviously you could specify it over here, but then it would be part of the OCR artifact. So there is, and now I hope it is secure, true, and we can test if that's the right one. Okay, let's say that, right? And being able to use interpolation syntax over here allows you to do things like, for example, redis colon slash something like that, right? If you want to combine multiple application variables into a single value. So I think it is either secure or sensitive. Let's try spin up. I don't have to build. Okay, it's secret.
Secret.
There we go. Yeah, this is okay. Then it's secret. Okay, so if you push your app to Kubernetes, or if you push your app to as an OCR artifact somewhere, right? Obviously, the default values specified or hard coded over here are part of that one layer in that OCR artifact. The other values are read when the application is bootstrapped, right? And that means we have to load them from somewhere. And from somewhere could be a Kubernetes config map, a Kubernetes secret. It could be a HashiCorp Vault instance, and so on and so forth. So there are different like configuration data providers supported by Spin that you can integrate to load those values instead of hard coding them, as I did with the log level, which I could override, obviously, or to bring the config connection string maybe from a HashiCorp Vault, which is like way more realistic data storage for sensitive data than an environment variable or a config map. Yeah.
Nice.
So
Thank you.
that's the way how you could prevent yourself from leaking sensitive information in the first place. But still, I mean, even if your workload does not require a sensitive configuration data, it is still your IP, right? So you obviously can use things like Spin OCI login or Spin registry they're an alias, right? For registry, OCI is an alias for the registry command, and there is an login command that you can use to authenticate against your protected OCI registry before pushing there.
Awesome. Love it. All right. Anything else you want to show us, or can I move us back over to big face mode?
Let's move back to the face mode.
Right. That was awesome. Such a good demo. Thank you for taking almost 90 minutes out of your day to sit and guide us through that. I love the trajectory of where Fermyon and Spin are going. Being able to deploy this to the Akamai network, I think, is an absolute game changer for people that need to write performant applications that are customers and users around the world. And I'm very excited to ship some of my own stuff this way as well. I've got a lot on my to-do list now.
Awesome. Yeah. From my point of view, thanks again for having me here at Rawkode. It was an absolute blast to present and talk about Fermyon Wasm Functions. And as I said at the beginning, it is it is a preview, and we if you want to explore it, if you want to run something there, just sign up to get access. We are happy to let people in, and we are listening for feedback. So there's a feedback command in the CLI. Just let us know what you think
Awesome.
about it.
All right. Well, thank you for your time. To everyone that watched, enjoyed, and thank you for watching. And we'll see you all next time. Have a great day.
Thank you. Bye-bye.
Thanks for tuning in. We hope you learned a lot. I did. Coding questions, comments, or a chat. The Rawkode Academy community is where it's at. Hit subscribe so you won't miss a beat. More live streams, tutorials, can't be beat. Keep coding, keep learning. It's the Rawkode way. We'll catch you next time. Have an awesome day.